All right, welcome everybody to session number 17. This is on-prem agents. We have got a magnificent demo teed up from The Wiz, and we've got a real challenge for you guys to go ahead and build, ship, and share something awesome today. Now, speaking of building, shipping, and sharing, I would like to go ahead and just shout out all the amazing outside of class building, shipping, and sharing from the cohort again. Oh, that's right. You guys are heads down. You guys are in build mode right now, but that's okay because Share Week is coming up. We're going to kick off Hack Week next class. And I just want to do a quick shout out. Now is about the time that you guys might want to start thinking about joining our weekly community, local, sort of on-prem in the community session that we're there every week. I wanted to do just a special shout out to specifically Ashwin, who's showing up to the weekly meetups, building, shipping, and sharing. He's doing the hard mode stuff. We'll shout the homeworks out like typical. This is really for the special outside of homework bounds. And I really, really want to encourage you guys. Also, shout out to Felix Ultima, Andrew, for joining us as well. I really want to encourage you guys to join us because this journey, it doesn't stop next week. It's really just getting started. And, speaking of next week, I know some of you are probably thinking about this already. We don't need to worry too much about this. But what I'd like to do is I'd like to encourage all of you guys now to go ahead and share with your network that Demo Day is coming up, and hopefully that you'll be presenting for Demo Day. We've created the event. We've started ironing out exactly who the judges are. We've started building the run of show, and we need your help to be able to complete our marketing materials so we can really amplify this, so we can send it out to our now 13,500 folks in our newsletter this weekend, so we can promote it a few times, so we can shout out the specific projects that are coming up, and we can give you guys more easy ways to share what you've been building and what you're going to ship next week. Now, you might be wondering, like, what am I supposed to submit exactly? I just want to address this right now. It's not that deep, especially right now. What we need from you so we can promote this is the same thing that I need to create when I do events. What I need to give Sarah is I need to make sure that she's got the title, the description, and then we can set everything up. That's what we really need from you by Thursday. You'll notice on the screen there's two due dates. There's due date number 1. We need you to fill that out by this Thursday. Also, that will help confirm your demo day presentation spot. Right now we have 18 slots allocated. So it's first come, first serve. Let's see if we can fill those up. If we could get 24 slots, then we'll just need to get some more judges and some more folks to actually administer rooms. But we've got 18 now. That historically has been a very good number. Get it in while you can this week, please, so we can promote. And then you can also submit just a blank repo, a blank slide deck. Just having created it will actually alleviate some angst, okay? Just, I promise it will. And then due date number 2 is next Tuesday, where we want you to go ahead and freeze that code, focus on the presentation after next Tuesday. Next Tuesday is going to be rehearsals. I want you to show up. I want you to put your rehearsal clothes on. I want you to get your mic and your light and your everything set up. We'll talk about that more on Thursday. This is a really important thing because you will screw stuff up, and you should do it in rehearsal, not during demo day. Okay, so this is going to be something we want you to share, and we need your help so we can share. So we're building, shipping, and sharing together. Just a quick, note on the date here. This is today. So you should be building this weekend. And we're actually going to tee up some times that make it easier for you guys to build. We've got office hours, of course. We're going to try to add some additional hours to Hack Week. With all that said, don't worry about any of that right now because we're talking on-prem agents today. We're going real deep into it. And if you worry too much about that, you just won't be able to get a lot out of today's session. Also, join us this week. we've got a couple sessions. Optimization of LLMs this is something Wiz and I have been trying to put together for a long time. I'm quite excited to launch it tomorrow. Also, Jacob, you get 30 seconds. Tell us about this one. This is your session.
Yep, we're gonna do a community session on AG2, which is another multi-agent orchestration framework. I'm gonna be joined by Mark. So Mark is a senior engineer at AG2, so we're gonna hopefully dive pretty deep, but we'll start with the basic building blocks, and it should be a fun time.
That's right. So beginners are welcome. And not that anybody
Beginners are
is a
welcome.
beginner, but
Yeah,
even bring your friends that are maybe thinking of getting into it.
yeah, exactly.
From zero to AG2 hero. Thanks, Jacob. Also, Vincent is doing a special deep dives edition this week. He's doing a double feature. So he's doing more stuff this week because obviously next week you guys will be kind of tied up building, shipping, and sharing your demo day stuff, talking guardrails, and he's also there for additional project support during Hack Week. I also just wanted to shout out each week, Mike C., one of the peer supporters, you guys might know him quite well, shares awesome events around the ecosystem around San Francisco, but also just around the internet. And he's always sharing hackathons and really cool things that you can get into every weekend. I want you guys to just start thinking about this stuff. Maybe join us next Monday to see what's going on at the end of the week, or maybe the next Monday after you take a week off. Also, as you think about your future, job opportunities abound. First thing in the spring, it was 70 degrees here today in Dayton, Ohio. I don't think that's a coincidence that people are hiring. It's classic every year. The thaw has begun. We have folks that have been peer supporters for us posting job opportunities in here, like Legends. Nitin's looking for an intern. We've got Robert looking to hire someone else for co-experiences. And the right candidate here, it's not an AI engineer exact thing, but if you're more of an AWS backbone for AI systems type of person, Robert wants to hear from you. And then finally, Akash, who started his startup out of the last cohort. The two co-founders met during AIE4. They're hiring contractors, and Akash is an absolute legend. He would be a really, really great, highly, highly technical person for you guys to work with if you're looking for that sort of whiz quality kind of leadership to learn from. And then also we have always folks in our ecosystem are looking for strong candidates. By the way, these two guys that are connected to people looking for strong candidates will both be there on demo day. Okay, and with that, let's go ahead and get into the homework. I think we saw some great stuff for homework 13. Advanced Rack. Kat, tell us what you saw looking through this.
Yeah, so hello. The homeworks went really well. I feel like all of you did a very good job. My only thing to say maybe is like make sure like when you submit homeworks to put the correct links. There were two students who submitted the wrong links to the wrong homework, so I couldn't really grade that. Otherwise, yeah, it seemed like everyone really understand the retrieval methods very well. I feel like, yeah, you will see on the grades. It went
Nice.
well than the homework I graded before. So,
Excellent. And if you guys are still submitting, I mean, you've really also placed yourself in this upper echelon of folks that have stuck with it. We're seeing that consistent 34 or so. Remember, there was about 60 folks that started, and you guys are still around, still crushing it, you know, really out here on this edge. So the awesomeness of RAG is beginning to sink in, really looking at different metrics and understanding data quality. That's when you know you're becoming an expert, is when you go back to the data, thinking about cost optimization strategies. This is something that we've started to talk about now, and we will continue to talk about through next session. What's the right balance of performance metrics? All I can say is you guys are asking the right questions. Great job sharing these homeworks, guys. Keep it going. I'm sure people in your network are definitely taking notice. I know we are. And we're loving all of the action from Ben and Ashwin, of course, to Krishanu and Deep T. Just the regulars are out there shipping and sharing. Ask them. I bet it's getting easier for them. So you liked last time, you know, a lot of you thought it was super useful as we've gotten into this production stuff. Great. You know, in terms of suggestions, Some of you felt like maybe it was a bit rushed. Well, it's a lot. I will continue to try to really dial in the storyline so we don't feel like we're rushing. Our apologies. The collab link was actually just the wrong link. So those of you that worked local, you had a really good time. It just worked. Those of you that didn't, you kind of probably had more of a bad time. I wish there was a video walkthrough or tutorial to use LangGraph Studio. There is on AI Makerspace's YouTube, and also, of course, on LangGraph's and LangChain's YouTube as well. So if you're looking for something specific, let us know so we can maybe add it to next cohort's curriculum. A little confused between difference between embedding and response caching. I'll try to explicate this better next time. I would like to know how to debug complicated LLM code as a developer. Yes. Yes, we're getting somewhere. That is the right thing to say. That is the right thing to think. Wiz said yes, me too, when I showed him this one earlier. Second breakout room, pretty confusing. It just worked. This was a local one, so some of you guys had a good time, some not so much. In addition, well, Wiz, this is a question we need some help with here. In addition to running LLMs async, what else should be considered when serving multiple users simultaneously?
So basically, you know, depending on how many people you have interacting with your system is going to dictate what kind of hardware you need, what kind of, how many nodes you need, for instance. But that's really it. I mean, most of the ways that you build an application, if you're using like Fast API and then whatever front end you want, are going to handle sessioning for you. The big thing is just making sure that you're putting your application behind a load balancer. These are not things that we'll cover in class, but like, you put your application behind a load balancer, everything like that. Traditional application design, but the biggest thing for us is hardware. How much juice do we have?
I'm glad you're bringing up hardware today. It's apt for the discussion. So let's go ahead and align ourselves to the day here. I've got some preamble for you guys, and then we're going to get into a big old demo. So today we cover on-prem agents. Next class, we'll cover inference optimization. We're going to basically give you a bunch of trailheads again. And we have to also talk about rehearsal a little bit on Thursday as well. So by the end of the session today, really, this is a great just chance for you to just ignore kind of the world and deep dive into this. We want to know what we should be considering when we're setting up our apps to run on-prem. We want to learn how to serve up our agent apps that we build with LangGraph and that we then deploy the app so that we have our assistant that's actually being served up. Not just the LLM, but we need to be able to deploy the LLM to an endpoint. Not just the vector store, but we need to be able to deploy the vector store to an endpoint. So we're going to get an open deep research agent application up and running locally, and then you guys are going to have to add a RAG component to it. So it should be quite a lot of fun, the challenge today. We're going to talk on-prem, we'll talk model hosting, we'll review LangGraph platform, and then we'll get building. Okay, so let's get into on-prem. What is on-prem exactly? Well, it just means it's on the local premises. And this is probably, too fancy of a word to use. It's like in the house or the building, right? So it's like in your business or in your house. It's just not in someone else's businesses or house. It's not in the cloud. It's not being run on AWS servers. It's not being run on GCP servers. It's not being run in some big server farm. It's being run on your hardware. And so one of the things that's important to consider, given the context of our discussion we've been having so far, is that when we think about on-prem, we also have to think about what is not on-prem. And that's not the same as saying production. So when we're in production, we can have something on-prem or we can have something in the cloud. So we could deploy, as we'll try to today, an agentic RAG application to production. We can do that in the cloud. We can also do that on-prem. The thing is, as Wiz was just kind of saying, is that when we're dealing with LLMs, they're called LLMs. They're large, and they need a lot of GPU power. Now, we need GPU power for different things when we're dealing with these. And as you get more and more into building custom applications, you'll see some of this. We need it not just for inference, as we'll talk about kind of today, and we'll talk about more on Thursday, but we also need LLM horsepower for training. We just open sourced a course that some of you guys took. Shout out to all of you supporting our community that allow us to kind of open source this. But this is a great place for you guys to pick up if you're interested in learning more about training. Now, the point is that LLMs, they run on GPU. That means chat models, that means embedding models. You'll see memes like this. And the point is that while LLMs run on GPUs, GPUs are using compute and they're using memory. And it's important to understand both of these things. So let's just sort of recall, like when we're serving up a model, we're allowing that model to have inference done. We can sort of put something in, get something out. And we do inference on GPU, but we should say like after we load it into memory. You know how we're like downloading the models and then we're like trying to quantize them and then we're like putting them into the GPU memory. Well, this is really important, especially when it comes to choosing hardware, to understand this kind of thing. I want to show just a quick clip here for you guys to sort of visualize this. And then Sarah, maybe you can tell me if it's too loud.
Perhaps some of the most important components, aside from the GPU, are the 24 gigabytes of graphics memory chips, which are technically called GDDR6X.
Okay, you guys have heard of DDR, et cetera, kind of RAM. That's what we're talking about here. What's the point? Well, the point is that when we have to like load stuff onto the chip, we're shuffling this sort of memory around. We're shuffling the weights, right? Like we need to load the model in. And this is quite annoying. This is why we see things like flash attention. This is something you'll read a lot in the first paragraph of many papers. Transformers are quadratic in sequence length when we think about time and memory complexity. So that is when we think about like how scalable this sort of model is, this sort of algorithm that we're running, this inference that we're doing, as my sequence length increases, I need to think about how this is going to impact, especially as I go and I try to scale these applications, how many like individual little, we got this great GPU means fancy calculator kind of idea here in the chat. It's like, how are we going to get the right amount of fancy calculator for this? And this is where we see things coming out, and we've covered these on events. We'll continue to cover these kind of things. Where you read something like flash attention, and it says it's an I/O exact attention algorithm that uses tiling to reduce the number of memory read writes. And those memory rewrites are between GPU high bandwidth memory, HBM, and GPU on-chip SRAM. And then you're in this like, acronym soup, and you're not quite sure what's going on necessarily. It's important to start digging into some of this stuff if you really want to start digging into some of this stuff. Not everybody needs to build on-prem solutions, but if you are the kind of person that's interested in getting down into the hardware today, you should start looking at it. When we think about HBM, this is not directly attached to the processor. When we think about on-chip SRAM, guess what? It's directly attached to the processor. And when it's directly attached, we can move faster. So we want to think about like high bandwidth memory is kind of like to the hard drive, classic hard drive, as kind of GPU on-chip SRAM is to RAM. And I want to show another quick clip here for you guys, just sort of, it's like real quick, just to visualize.
From the solid state drive into these graphics memory.
So this is the idea of like moving from a solid state drive into on the chip. So you might have to do this shuffling. And the reason is because, well, GPU stands for graphics processing unit. They were never really built for LLMs. And so what we see today with people building new chips is the sort of bottleneck we have isn't actually compute, but it's memory. Because memory access, turns out, is slower than computation. Now, we're writing better, programs, kernel fusion. We're doing all this sort of stuff down at the hardware. This is like what Unsloth team is working on all the time. But in the meantime, until one day we get everything figured out and we have perfect everything, which of course, if we did, we would just use a bigger model. So this is sort of a never-ending game. We need to essentially always be talking about using smaller performant models. This is the idea of putting something on the edge. It's not in the cloud. It's not on-prem. We want it on a device, right? Because it's smaller than what we can put in the cloud. And also maybe we need to move it around. Maybe our prem isn't in a house or at our business. Maybe it's literally in the field. We want to stand up a lab in the middle of a war zone, right? And this is the kind of thing that people are quite interested in doing, putting it on robotics devices, that kind of thing. And when you start to dig into some of the models that are coming out, like for instance, Llama 3.2, that's right, Llama 3.2, not the multimodal, but rather the on-device right-sized ones, 1 billion, 3 billion. And that's the kind of size today that we're wanting to leverage when we're really, resource constrained, whether compute or memory constrained. Also, models like DeepSeek R1 that we'll use today are quite performant and they're able to sort of, give us good results without massive compute. Okay, back to on-prem. So how does all this come together? Well, we can ask, like, did GPUs with video RAM have to be on-prem? It's like, yes. Well, what about CPUs and RAM and hard drives? Well, it's like yes, obviously. And we know the software kind of pieces we need. We need the LLM, we need the embedding model, we need the vector store, we need the data, we need the agents, right? And so now we know the hardware we need. But the question is like, well, how do you sort of figure out how much you need for what thing? Well, that's a tough question. What we can say is we can say that for each of these pieces of our puzzle, we need to think about what kind of hardware we need. And interestingly, while the models are going to run on GPU, the agent actually runs on CPU. The data actually, just needs to be kind of stored somewhere. The vector DB doesn't run on GPU either. And we're going to ask you to set up a local vector DB today as well. So all of this needs to be considered if you're going to start building things on-prem rather than just completely outsourcing it to something like AWS. Now, people ask, well, why should I, use a managed service? Why don't I just set up my own AWS? Well, it's like, well, if you don't know all this stuff, then a managed service might be great for you because it's basically you're paying an automated AI engineer to figure this out. And yeah, you're going to pay a little bit more, but are you going to pay more than the $200,000 and $250,000 a year that you're going to need to pay like a proper AI engineer to cost optimize everything? When you have no users? Of course not, right? So let's go ahead and get into hosting, the stuff that's hardest to host. We want to talk about the models, okay? And what we're gonna use today is we're gonna use Ollama. Now, Ollama is great. It just kind of works everywhere. And this has been proven by the industry time and time again. So some of you are on Windows, some of you are on Mac, you can kind of take Ollama anywhere. It's great. There's other things that you can use. VLLM. Remember we saw text generation inference from Hugging Face inference endpoints. There's things like NVIDIA NIM. But really, like, when we think about portability and getting up and running quickly, Olama is just going to be a great place to start. And so that's why we're teaching it to you. And hopefully, as you guys are seeing, of course, you can go deeper on all these things. And we try to do that on our YouTube channel, but I want to give you that golden path of at least one really good option that you can go with. Now, importantly, too, when we talk about serving, Olama is an inference server. So that means that I'm going to serve up the model so I can do inference. But if I talk about like LangGraph server, I'm not serving up a model. I'm serving up an application, right? What's an API, right? Throw it in the chat, right? It's like, that's the interface for my application, right? And so like, that's how, if I actually build the agent, if I build an assistant, I can interact with it directly via API, not just the model, but actually my whole app. And so this is the real key distinction that you want to make sure you make in your mind, talking about applications being served up to APIs and endpoints versus just LLMs or embedding models being served up to applications, to APIs and endpoints. Because in order to serve up a fully functional open research agentic RAG application like we'll build today, we actually need to set up endpoints for embedding model and for chat model as well. So there's endpoints within endpoints. And so we get more meta. Thus is the story of digital application development. Okay, so LangGraph platform, we talked about it a little bit already. When we talk about using this platform, they've obviously built this for enterprise. And, there's some stuff in the chat here about, constrained environments. These are the kinds of things that they're selling to folks. Hey, you want security, you want privacy, you want it all, we'll give it to you, just use our platform. Now, for those of us that are just sort of hackery builder folks, we're going to go in and we're going to just self-host. This is kind of what Wiz is going to show us today. And importantly, this whole thing was just kind of a rebrand of LangGraph Cloud, which probably is an easier way to think about what's actually going on. Is it in the cloud or is it on-prem? Wait, LangGraph Platform is what we're using to build on-prem, but it used to be called LangGraph Cloud. It's like, yes, welcome to the way things are done with LLMs today. They kind of built this LangGraph Studio, this agent IDE, and everybody liked it. And they had LangGraph Cloud, and that was dope. And then they were getting feedback from users, and they were like, hey, we really like this agent IDE. And then they started to kind of put this together with a previous product that never really took off called LangServe. LangServe was a way to sort of directly deploy your app with LangChain to an API. So this is all kind of matured and come together into now this LangGraph platform. And we'll use LangGraph Server. We'll get access to LangGraph Studio by doing that. And you can still, I think, use some of these other things like LangServe, but I wouldn't be surprised to see these deprecated in the coming releases. This is something that we covered December 2023. So this is quite dated now. Now, finally, we want to consider if we're actually on-prem, we might have a lot of privacy requirements. We might have a lot of different constraints from the people that we work for, the people that we do work for. We might have a lot of regulatory environment stuff and compliance stuff. We might have to set up internal APIs, and those internal APIs are kind of on our own little, people still have very, very dated clusters that they use for their on-prem setups. If you're in this sort of environment, all this stuff still holds. You still need to think about all of this. You probably just can't use the biggest models out there today. Maybe you have to use really, really small models until you can get some new GPUs. And so, the evolution here has brought us to this. It's taken us from LangGraph Cloud to LangGraph Platform. And this really allows us to kind of deploy agents at scale. That's what LangGraph is hearing from their users. That's what that's what they were hearing from enterprise. And that's where we are today. So that's what we want to show you guys how to do. Okay. So let's start doing it. Well, let's build an on-prem deep research agent. We've already seen this. We're going to take Open Deep Research. That is this whole setup where we have a planning agent, reflection agent, all these different pieces, very cool. And we're going to set it up so we can actually just use Olama. and we can use local stuff. And we're not going to just deploy this any old way. We're going to deploy it like Wiz will show you how he's deploying it on his local, and then you guys will get the chance to deploy it on yours. So that means we'll use DeepSeek R1. We're going to set up a quadrant vector store, and we're going to do that locally. So you guys will get to go into the resources and the docs here using the Python client to create a collection. And we're going to use some data that's near and dear to Wiz's heart here. We're gonna ask it questions about Dungeons and Dragons. He's actually a avid D&D player, and from what I understand, pretty legendary, although I haven't played much myself yet. And remember, like, as you're doing all of this, think about, what would my constraints be? What are they now? And if I wanted to really take it to the next level and talk to, I don't know, the big boss of my enterprise, what do they want? Well, of course, they want it all, right? They want fast response times. They want high accuracy. They want low cost. They want scalability. They want everything version control, tested, all the logs, all the alerts, all the security, all the data privacy, all the cost optimization. And until you get all of it, can't do anything. And by the way, make sure you're doing all of this too. Well, you are out of the box. You could tell them that, right? So with that, I'm going to hand it over to Wiz for the on-prem deep research demo. Wiz, over to you.
Okay, we're gonna prem on. We're gonna start with the worst view that you've seen in the whole cohort, but it's everything all at once. Okay, so we replace current share. I'm gonna share my entire screen. Boom, here it is. So this is what I'm looking at. Don't be scared. It's all good. So what we're gonna kind of walk through is the different things that are happening on the screen. We're going to first start with our research topic. So this is the end, and I know this is very difficult to see, right? We're not worrying too much about that for right now. We're just showing each of the moving parts. So in this particular window, we have the research. So we're going to say, like, what kind of class should I play if I like nature and magic and stuff in D&D, and we're going to put 5e. And then we hit submit, and it goes. You'll notice that the Lang serve is going to motor through some API requests. We're going to ping an endpoint over and over again, get some stuff, learn some stuff, do some stuff. It's going to be fun. There you go. Easy peasy, lemon squeezy. Yeah, it is Windows because we test everything in WSL. Let's go. So this is going. That's good. I've got a version here that was already done, which we can look at, and it kind of brings you through it's the same output, right? That the same output that we saw before, right? That when we use the OpenAI version, just like not as good. Okay, that's the thing, because we're running these models locally. So what models are we running locally? Well, first we have our embedding model, which you can see we can give queries to and get walls of numbers, just like an embedding model would do. We also have our actual DeepSeek model. So this is DeepSeek 8B. This is a distilled and quantized version. So we can go ahead and put that in. We can see this thing just motoring, right? Just working through this very quickly. We can see in this window we have Quadrant. Quadrant is our vector store. So if we ping Quadrant with stuff, we'll see that appear here. And then finally we have NVIDIA SMI, which is our NVIDIA display. And you can see that we're using about 11 gigs of our GPU memory to do all of this stuff that we're doing right now. So that's all this stuff that's running. Okay, we're gonna stop share. We were seeing it work, and we're gonna slow things down a little bit now. We're gonna go to how we get to that stage, right? So that's the final product. For those of you who don't love Windows, don't worry. We're going right back to cursor. Okay, so here we go. All we need to do to get all of that stuff going, right? Mostly for visual effect more than anything else. The idea is that we want every one of those things running. So the first thing we have to do is look at our README, and in our README, we're gonna have our instructions. I'll zoom in a little bit here. And the idea is that these instructions are very straightforward. We have to download Ollama, and then we have to pull the model we want, right? Once we've pulled the model we want, all we have to do in order to get started with that model is use the command Ollama run, and then we're going to put in our the correct address. And what this is going to do is be DeepSeek R1 8B. So we'll just do that here. And you can see now we're able to use that model. So we can say like, hey there, and then we're going to get a bunch of tokens. Nice. The thing about Ollama is that even though we have this running, it's not always serving the model. This is something important about Ollama. So when we choose to use the model, we're going to be able to hit that model. Otherwise, it's literally just chilling, having a good time. So we've pulled DeepSeek R1, and we've seen how we can run it. Just change pull to run. Cool. Next thing we need to do is get the modified deep research repository. You will all have access to this. And what we're going to do in there is we're just going to look at what we're actually doing, right? So the deep research code. It's the same as what we saw before. So what we'll do is we'll open it up so you can see it. We'll go here. We'll go to Ollama Deep Researcher. We'll open this up, and you'll see that we have the same setup that we had before, right? Where we have this assistant. Our assistant has this graph, right? The graph is important, but the assistant has this graph, and what we want to do is, basically be able to run this. And the way that we run this is extraordinarily straightforward, right? We will basically just get into our deep research, directory, and then we're going to do the old UV run langgraph dev, and that's going to spin it up, and then now we're using it. Okay, there you go. So that's all we've got to do for getting these things running, right? Very straightforward, not too difficult at all. There's this next part though, right? So the next part is, well, now that we've got it running, we're going to head back to our AIE5 repo, and now we're going to think about, like, what do we want to do with this? Because out of the box, it's going to do what we want, right? That's great, but we want to do something interesting. So what we're going to do is, in the README, we have our actual assignment, right? Which is just add local RAG powered by Quadrant to the existing agent, right? So we're going to need an embedding model, which I showed you in one of the terminal windows. And then we're going to need to launch Quadrant through Docker. We're going to create a vector store leveraging Quadrant as a backend. We have a notebook that's going to help us to do this, which is this notebook. All this notebook is doing is it's setting up the actual Quadrant, so that you can use it. Easy peasy lemon squeezy, and that's it. Once we have it set up, we just push vectors into it. You'll notice that we have a URL that we point to. This is because it's hosted on whatever we're using. In this case, I'm just doing it all in one system, not using my server to keep it nice and straightforward. But that's the idea. And then also what I'll do here is I'll add what we'll do it live. We'll add the import that we need for this to work, so you guys have a more pleasant time. And then we'll go ahead and we'll commit and push this live again, so you have not a terrible time. Okay, and you'll notice how I do things in my terminal. A lot of terminaling today. If you're into that. There we go. Okay, perfect. Now it's up there and we're happy. So once we have Quadrant set up, and setting up Quadrant couldn't be easier, right? What we're going to do first is we're going to do Docker pull quadrant / quadrant. So it's going to look like this. We're going to run it. It's for you, it might take some time because it's going to actually download the container, but I already have the container. So boom, it's just already there. And then what we're going to do next is we're going to actually run the thing. And to run the thing, very surprisingly, we're going to use Docker run and then a bunch of other things. I'm not going to run this because it's already running in another terminal, but this is all you need to do. This is verbatim from the docs. Yes, Docker run. Sorry, guys. No, it's the best. Okay, so now that we've got Docker running, we need to add, information to our graph, right? So basically, the assignment, what you guys have to do is this component here, right? Which is just add local rag powered by quadrant. We're gonna need to get the embeddings, no problem, and then we're going to, of course, do the old, the old adding to the rag. That's it. Let's look at where we're gonna add that in the actual deep researcher directory, so you can see what we're looking at. And what we're gonna do is we're actually gonna add that in our graph.py file. So you'll notice that our graph.py is where all of our nodes are, right? We have our generate query node, our web research node, our summarize sources node, our reflect on summary node, our finalize summary node, and our route research node. You'll notice that all of these nodes are super straightforward, right? Then we build a graph, and you'll notice that all of these graphs, or building this graph is also super straightforward, right? We plop all of our nodes onto the graph, and then we connect them with edges. So what you guys are going to have to do is you're going to add a new node here, right? So you're going to do new node here, and then you're going to need a new edge, right? So, we'll say like new edge. Now, what I would suggest you to do, right? So, and let's call this like rag node, right? What I would suggest you to do is I would suggest you to add an edge from generate query, right? To the web research node. And then you're going to need to overwrite this node, right? To reflect the new node, or sorry, generate query to new node, and then you're going to need to overwrite this to, instead of go from generate query to web research, go from new node to research. That's it. So the basic idea, this is all you really have to do, right? Like, which is build a node that does rag across whatever data set you want, right? Using quadrant, that's going to be running in a Docker container. And then you add the node here, and then you put it somewhere in the flow. It can be anywhere in the flow. It doesn't matter. Just so long as it is in the flow. We're going to suggest we're going to suggest that you do it here, but you certainly don't have to. That's the whole assignment. So it's going to take a little while to get through things, get things running. There's not like a specific way that we want you to do this. Basically, we just need you to build a rag node, add it to our graph, and then connect it into the flow of the existing graph, and then run the thing. You might ask, well, what about state, right? So we have our state object, and you'll notice that our state object has web research results, sources gathered, right? You can either just inject the context you find into web research results, or you can you can add a modification of state. I'm going to recommend you add a modification of state, right? So like maybe we'll say something like, rag research results, or whatever it is. Imagine I can spell fast, still getting used to this keyboard, unfortunately. Rag research results, there you go. Okay. Or you can just shove it into web research results, totally up to you. But the idea is, right, this is not a on Rails assignment. There's not a correct way to do this. This is the job, right? We have this agent system. It does this thing. Now you need to make it work in a different way. You need to add something to it. You need to add a feature to it. In this case, we're going to have the feature be consult local sources first, right? Which is what we called rag. Yes, as well. So there are 2 repositories that we're using today. So I'm going to actually stop sharing my screen, flick one more time through a wall of screens. But the idea is that we have 2 repositories that we care about today. The first one is our usual repository, which is going to be our AIE5 repository. And then we also have OLAMA Deep Research Modified. So I'm going to share my screen so you guys can see this. And the reason that we've done this is, once again, this is our normal AIE5 in on-prem agent. You know, you'll have the things to test this system, make sure quadrants work and stuff like that. But it's going to point you to this repo, right? Clone the OLAMA Deep Research outside of AIE5, outside of, please, to make sure that you don't wind up with weird sub repos, right? So if you just copy and paste this, it'll do this in your home directory. But the idea is that you're going to go to this repo to download the actual application, which will be an src/assistant, so source assistant. And that's where we saw our graph. And feel free, right? Feel free to add to prompts, right? You can do this just in the graph. You can add everything you need just in the graph, or you can follow the pattern that exists here, right? Feel free to leverage Cursor. Cursor's great at helping with these kinds of things. But this is what we're doing. There is no rubric, right? We're add rag. That's the assignment. It should be straightforward. Running OLAMA models should be straightforward. Your peer supporters are armed with a bunch of informational or additional information to help you if you get stuck in weird little spots. But this is it. This is what the job is, right? We've got this app. Please add a feature to it. So that's what we're asking you to do. This is how we're asking you to do it. And the only time we leave our premises during that whole flow that you saw, right? The only time we go outside is when we search the internet, right? So when we use Tavili. That's the only time that we go outside of our one single computer that we have sitting on our desk or in our labs. And that's it. There you go. Okay. I'm going to pass you back to Greg. We're getting warmed up for a real breakout room, a powerful breakout room. We'll go back to Greg.
Yes. Okay, Wiz, I want to keep you up here because I want to just have a quick chat. I'm sure people are wondering. So, we talked about a couple of things, and, we've had a similar discussion with all of the different types of hardware and software, or specifically pieces of our RAG and agent puzzles. There are other things we could use. For instance, VLLM seems to be out there crushing it, virtual LLM. And, it's like, I heard it's cool and pretty dope. And you're telling me that I should pick OLAMA. So I want to just quick discussion first. Why did we choose OLAMA? Why is it the best for us today? What are some trade-off considerations that you make when you think about choosing an inference server? Muted.
So I would say I would not really use OLAMA unless I'm hardware constrained, right? Which is why we're using it today. So most people don't have access to a GPU, right? They do have access to a computer which has CPU and RAM, but they don't have access to a GPU which has a GPU and GPU RAM, right? OLAMA is great because it runs on like pretty much anything. It can run on a toaster, right? Like it can literally run on a toaster. People have done this. And so it's the fact that that's very flexible, fits a number of environments, works on Mac just as well as it does on WSL2, right? That's why we're choosing this. If I wanted to go big, if I had discrete GPUs, if I had a node, right, then I'm reaching for tools like VLLM. I'm reaching for tools like TGI. I'm reaching for, of course, NIM. Small bias there, but NIM's great, and or SGLang, right? It's a kind of newer version of one of these. But each of those even has its own trade-offs. Like for instance, VLLM is extraordinary when it comes to latency. So you get lots of tokens very quickly, right? From one single stream. TGI, it's kind of in middle of the road for both. It's not very latency is not amazing, throughput's not amazing, but it's okay on both. And then NIM, right? Incredible throughput, crazy throughput. So if I have tons of users and I just need to, they're all smashing me with requests, and that NIM is going to be very useful. But this is the idea, right? So the idea is that each of these is tailored for a specific use. What I would say, if you're out there in the wild and you want to get started and you just got a GPU, lock in VLLM. They're extremely agile. They work very quickly. There's no licensing. Just lock it in, use it. It's fast. It's good. It's stable. You'll have a great time. Maybe as you approach larger scales, consider tools like NIM. But for when you want to get going, go VLLM. So long as you have GPU. It doesn't work on a Mac, for instance, right? Like, it's not going to run in on your local machine unless you have a GPU very well. But once you have that hardware, right? Once you have a server that has GPUs, whether it be on your premises or whether it be in the cloud, that's what I'm going to reach for VLLM for sure. Yeah.
VLLM. Okay. And
Yes.
and then fun fact, we had VLLM in this very assignment last cohort, and people had a bad time. Okay, because Olama is more fun for you guys. All right, so that's part of the reason why we're choosing it. Okay, but we do have lots of content on VLM if you want to dig into that. Now, one more question was, if we go up a level from inference server to this sort of API server level, of course, we get back to this, we're in the LangGraph ecosystem. We're in the LangChain ecosystem. We're using LangSmith. We're using Lang everything. When I look at LangGraph server, or when you look at LangSmith, they say, hey, it's the all-in-one developer application lifecycle platform, no matter whether you're building on LangChain or not. So everybody's doing this now. Everybody wants to be your end-to-end solution. When we think about serving up application level APIs, why did we choose LangGraph server here? I think it's pretty obvious, and also, if you were just generally looking for a great API server, what trade-off considerations are you thinking about?
Basically, like, we use it because it works out of the box with LangGraph. I mean, which is not surprising. Right? It's called LangGraph server. It serves LangGraph. But that's why we use it. I mean, straight up, that's the reason. If you're not using LangGraph, or if you're if the default APIs for whatever reason aren't good enough, which they will be, then you can look for going just a straight up fast API. There are people out there who really still do use Django, right? Even for stuff like this, they're using Django or Flask, if you can imagine. Back in the day, those are still great ways that you can serve these agent applications. But for the most part, we're just going to use LangGraph server if we're in the LangX ecosystem, and if not, we're just going to look to Fast API. In terms of trade-offs, especially between LangGraph server and Fast API, the only difference is velocity. Spoiler alert behind the scenes, LangGraph server is fast, like Fast API, sorry. And then Flask or Django, if you're already in those ecosystems, if you're already chilling in those ecosystems, then you're done. You're good. You're good to go. Yeah. Just stay
And
in
just to
the one
bring
you're
this
using.
full circle back to sort of the challenge that they did in the beginning. They deployed a Chainlet application, right? They've been putting these front ends on. How is Chainlet actually serving up the application on the back end?
Chainlit, same thing. It's just fast API.
Fast
Just
API.
a wrapper for Fast API.
And so if we want to sound like we're cool and we know, we have to just call it fast, not Fast API, right?
No, you should always say
Right?
Fast API.
Yeah,
Fast is incredibly confusing.
Yeah, exactly. Okay, all right. So there you have it, guys. That's serving models, apps, and now you guys can finally understand one of the dankest memes of all time. But we're gonna take a quick break, okay? And then we're gonna come back and we're gonna get right into breakout rooms. All right. So 5 minutes, break it out, shake it out, and then we'll dig in as teams to the breakouts. Into it. So it's time for breakout rooms, guys. This is going to be the sort of build challenge of the cohort. So we're going to be back in kind of a chill notebook session next time. When we get back from breakout rooms, I'm going to talk very explicitly about what to expect for demo day, what you have to deliver, what we expect from you guys. Spoiler alert, it's going to feel a lot like this breakout room. There's no rubrics. There's just getting it done. And there's just deliverables, just like real life. So see if you can add this RAG component, have some fun with each other, enjoy the time with your peer supporters and your journey groups. You get to see them one more time next class. And we've got 40 minutes dialed in for this one. We hope you guys have a good time, and we're excited to see how it went at the end of class. All right, we'll see you back in a while. Have fun, guys. Back from breakout rooms. We are 15 minutes shy of the hour. And if you didn't have a great time building on-prem, you shouldn't be surprised, because it's quite difficult to do this. It literally is all of the stuff all at once. And this isn't, and I want to be super clear, something that you really need to worry about. It's not something you need to worry about for the rest of the cohort unless you want to, because what you should be worrying about for the rest of the cohort is demo day. And I highly doubt any of you are going to demo anything on-prem. If you do, it will be a first for all cohorts we've ever taught. So let's go ahead and just wash our hands of that. You know, it was nice to see. It was nice to spend time with. We want to offer you guys the opportunity to submit that homework as extra credit, but there's no homework that's due from this week. That means homework assignment from today, homework assignment from Thursday, extra credit homeworks, okay? So we've been getting a lot of questions from you guys, and I want to go ahead and dig in a little bit to demo day right now, because we're getting a lot of the same questions, and we might as well go ahead and give you some foreshadowing of what to expect and what to think about, what to look for. I will remind you of all of this stuff again at the end of next class, because it's going to be important, because next Tuesday we want to rehearse. So the first question you might be thinking about is, what about certifications? How do I get on the list of people that gets recommended when, you know, I get an email from somebody in our partner network that says, hey, I need a list of candidates. Who do you got? We're trying to work on a way that we can easily get people looking for co-founders, easily get people looking for job opportunities, quick lists, and we can stay up to date with you guys on what your current status is and what you're looking for. If you're certified and you're obviously a legend, and we can vet that. The certification requirements haven't changed, but what we do need to focus in on is this third piece here: complete a final project and present during demo day. Note the grading certification benchmark if you're thinking about doing extra credit this week. The requirements for demo day are very simple. We need you to give us the title and 1 to 2 sentence description now. So I'd like us to go ahead and throw this into the chat now. And this is something I need from every single one of you, regardless of whether you're on a team or not, because we need to make sure that we have your information you'll see in the form. Beyond that, you need to have a public GitHub link to your repo that we can share in the YouTube video. You need to have a public set of slides that we can, again, share in the YouTube video. And you need to have a live presentation for demo day, right? So it's doing the thing. That is the video. Now, if you need to keep your code or your data or anything private, I'm sure you've probably been doing this already on some level with your midterm, and we can continue to work with you folks. We've done private demo days for people. It's something I highly discourage. If you're trying to build a startup, get out there and build in public. Do not be, I'm going to be in stealth mode about it. Okay, I've never seen that truly help anyone, but I understand if you're hung up on it. Okay. I don't see any questions other than can we demo on localhost? You can demo wherever you'd like, Ashwin. Yes. But the people that know when they see your demo, if they see localhost, they'll know. So it just depends. What are you aiming at? We're fine with it. What about operational success? Well, one of the things that is important to consider is that this is a true production, and we need to actually do it production quality. So for rehearsal and for demo day, we're going to do a tech check. That means your audio, your video, and your lighting. Most of you look terrible on Zoom all the time. No, I'm just kidding. But really, if you have never thought about it, you probably don't look that good. And we want you to look your best on demo day. We'll talk about this more next class. But you have 10 minutes for your demo. 10 minutes. There'll be a clock. There'll be a loud noise at 10 minutes. And then after those 10 minutes, there's going to be 2 judges in each room. Even though we're not judging you for certification, you will be judged during the demo presentation. 2 judges, 1 question each. Maybe they'll have a quick follow-up. You want to try to answer within 1 minute because we only have 5 minutes for questions for each demo. We're going to ask the judges to look for practicality. We're going to ask them to judge you. Technical excellence, presentation and demo quality, as well as originality. This is something that if you're interested in the data we get about your project, we're happy to share it with you after. Yes, Dirk, we know you're going to bring it. What to expect is that Tuesday in particular is dress rehearsal. That means wear your dress that you will wear. Okay? Dress generically. You don't all have to wear dresses. Okay? You just want to literally wear the clothes, literally take the shower, literally put on the cologne or the perfume that you would do on demo day. If you've ever done a true dress rehearsal for anything, you know that this is how they do it. Okay? This is your biggest presentation of the year, potentially of many years. And we can get it in front of a lot of people. So we want you to do well. We want 80% of your stuff done by the time you hit rehearsal. It doesn't have to be perfect, but we're not going to do this cam off, pitching thing. That's not what this is. If that's you, you don't get any time. You'll demo for your peers. We want you guys as peers to give each other serious feedback during rehearsals. Because if you don't tell me why I suck, I can't fix it. This is why we always demand feedback from you guys, because we can't fix things we don't know about. So please be ruthless, but do it with kindness and do it with generosity. Do it as a true member of the community, trying to help somebody build, ship, and share. One of the things that you want to think about is your audio and your video and your lighting. Don't have a stupid mic where you have tons of background noise. That is the number one worst thing you can do. Terrible mic will ruin everything. Everything else you can come back from. Terrible background noise will ruin everything. Then you want to get your lighting, right? So I've got sort of dynamic lighting here. You don't need anything fancy like this. Just get a little ring light, right? I can like increase the light, or like decrease the light. Even the lighting that's default baked in automatic on Zoom is pretty good. Even the mic on your MacBook is really good. We've tested a lot of this stuff. We're happy to answer questions if you have them. You want to make sure you have your screen set up. If you're doing this on one screen, you're screwed. Full stop. Nobody uses one screen in real life for big presentations. They have something that they're looking at. They have some audience they're presenting to. They maybe have some notes in their pocket. They're ready, okay? You need to be ready. This is my setup. You don't need this, but I would recommend at least 2 screens. Okay, quickly, to be successful with your presentation, it has to be a presentation. I need a beginning of your story. I need a middle. I need an end of your story. I want you to introduce me to somebody. I want that somebody to take me on a journey with them. I want you to tell me who this person is, what their problem is, and bring me into their world. I want you to avoid ridiculously ugly slides with many more than 6 bullets. 5 is better, 4 is better, 3 is better, 2 is better, 1 is better. Okay. Audio, video, and lighting, so important. Audio is by far the most important. If you're presenting and you don't know how you're going to start, you're screwed. If you start well, everyone will forgive you, even if you fumble after the start. You want to focus on the start in the first transition, and you want to get rid of words, put them into your slide notes, make sure your slide notes are up. If you have jokes or memes, those can be bangers if you deliver them properly, Nino. Now, if you think about technically what does success look like, Wiz, give us 1.5 minutes on this slide right here. These are your ideas, but I'm just throwing you in here.
Yep. So basically, the big thing to do with code is zoom in lots. Have separate tabs. So when wherever we're presenting something, we'll have the tabs set up like almost like a slideshow style, so you can just click to the next one. Presenter mode, if you're doing slides, you have to make sure you're in presenter mode. And then for code, this is slightly, different to the rest of the cohort. You're not going to walk through the code line by line. No one's going to get, no one's going to get like value out of you just showing people walking through the code line by line in like 5 minutes, right? Or less than really 2 minutes when you think about it. So just showcase just the high level workings. Architecture diagrams are great for this. There you go, code. Show some, but not all.
There you go. There you go. And then slow down on the parts that really matter. It's about timing and delivery too. Wiz does this naturally now because he has literally so much practice. But remember, nobody knows as much as you. They are seeing it for the first time. We're presenting to a general YouTube audience, even if the people in the room maybe are a little bit more advanced. From AIE 3, we heard people had very busy slides, way too much clicking around, screwing up the demos. No, nothing to be worried about. You'll probably do it too. Beefy diagram slides, openings that the audience can relate to. This is particularly something I enjoy helping you guys with, but you have to come to me. Assume they don't have domain knowledge. And then finally, help us share now. Put yourself on a deadline. Hold yourself accountable. Remember, our network is your network. We want to get out in front of tens of thousands of people. We've historically gotten 50 to 100 folks at these live demo days, and then your video will get hundreds of views in the weeks to come. If you share it as well, which you should start doing now on LinkedIn, share, repost this right now, share it to your network, then we can start to grow this thing together. Remember, you should be building this week, and this is the best week ever to build, ship, and share. Tell that story, just enough code. That's it for now. Today, we saw a lot. On-prem means at your house. We can do on-prem now. I need you to fill out your demo day stuff. Homework this week is optional. Vincent's doing deep dives. We got optimization. Jacob's got AG2. We got a lot of stuff this week. You should start coming to Build, Ship, Share meetups next week. But with that, I'm going to ask for 1 extra minute of your time, and I need your feedback on today. Let us know what you thought. We're talking inference optimization on Thursday, and we're talking rehearsals next Tuesday before demo day. All right, feedback in the chat. Let me get some vibes. That's feedback for session 17. So we covered on-prem agents this time, and we talked about demo day. We'll talk more about demo day when we cover inference optimization. Next time, we'll look at a couple of different techniques, including GPTQ, AWQ, which is kind of a best practice. We'll even talk about a little more an edge sort of technique called VPTQ, which even quantizes even lower. We're back to quantization with inference optimization. Again, none of the stuff we're talking about this week must make it into your demo, so please do share the demo day with your network. Please do share with us what your project will be. We can highlight it over the next week to our network and help us put together a really banger demo day. I think it's going to be the best one ever, and I can't wait to see what you guys start building, shipping, and sharing this week. We'll tell you more about exactly where to find help and support throughout Hack Week on Thursday. And until then, we hope you have a restful week. It's going to be a banger ahead. Maybe we'll see you on YouTube tomorrow. Maybe Jacob will see you for AG2 tomorrow. But if not, we'll see you on Thursday for inference optimization. Bye, everybody. Have a great evening. And thank you for the extra 2 minutes. Bye, guys.